Hello friends, today's session we are going to see some more topics regarding string handling. Okay, so we will start with string comparison. The string class that we have already seen, we will see it in more detail. The string class includes several methods that compare string or substring within the strings. One method is equals and ignore case. To compare two strings for equality, use equals method. Boolean equals, it returns true or false, and we are passing the string as a parameter. String is a string object being compared with the invoking string object. So whatever string object that we will pass before the equals method and full stop or dot, it will we will pass here the second string. So first string dot equals second string, it will compare the equality. It returns true if the strings contain the same characters in the same order and false otherwise. The comparison is case sensitive. Okay, so same character, same order means exactly same match is there, then it will return true. And when it compares to string, it considers A to Z to be same as A to Z in case of equal ignore case. So in equal ignore case, the case differences are ignored. Then it has this general form Boolean equal ignore case string string. Their string is a string object being compared with the invoking string object as in the previous example. It too returns true if the strings contain the same characters in the same order and false otherwise. Okay. And one more difference is that it does not care about the hey. It does not care about the cases there. Like A to Z capital will be same as A to Z small. Then demonstrate equals and equal ignore case. We will see hello, string S1 hello, string S2 hello, string S3 goodbye, string S4 hello. Okay. So S1, if S1 is equal to S2, exact match, it will give you true. Then S1 equals X3, it is not exact match, it will give you false. S1 equals S4, it is not exact match, it will give you false. And S1 equal ignore case S4, it is not exact match, but the number of characters and character sequence is same, hello, so it will give you true. Output is first is true, second is false, third is false, and fourth is true. Region matches. Region matches method compares a specific region inside a string with another specific region in another string. There is an overloaded form that allows you to ignore case in such comparison. Okay, specific region inside one string with another specific region in another string. Boolean region matches start index, string to integer start to string to start index and number of characters. So whatever string we will pass dot region matches and start index, from that start index to end, it will take one region, that is one string will be fetched from the first string. For example, if we are passing hello, okay, in hello, the first index string character is E, okay, HELLO. So from if I specify start index as 1, it will give me ELLO as a string that will be fetched. And in string 2, I am passing hello again, and for start index 1, and then number of characters 1 and 4. So it will also give me hello. Okay, ELLO. Okay, so LO is equal to LO. Boolean region matches Boolean ignore case. Okay, in that ignore case, your case sensitiveness is removed. Then integer start index, integer string to integer string to start index, and number of characters. Okay, so first the form is case sensitive and another is case insensitive. In both versions, start index specifies the index at which the region begins with the invoking string object. The string being compared is specified by string 2. The index at which the comparison will start within string 2 is specified by string 2 start index. Okay. The length of the substring being compared with passed in number of characters. Okay, so what is in short? The region matches first version of parameterized constructor and region matches second version. Both are same. Okay, so in the first version, case sensitiveness is there, and second case is ignored. Ignore case is true. The case of the characters is ignored. Otherwise, it is significant. Now starts with and ends with methods. String defines two methods that are specialized forms of region matches. Okay, so if particular string start with particular character, it will give you true, otherwise it will give you false. The starts with method determines whether a given string begins with a specified string, and conversely, ends with determines whether the string in the question ends with a specified string. They have the following general forms. Boolean starts with string, Boolean ends with string. Here string is the string being tested. If the string matches, true is returned, otherwise false is returned. For example, foo bar ends with bar and foo bar starts with foo. Both are true. The second form of starts with shown here lets you specify a starting point. Boolean starts with string, comma, start index. Okay. Foo bar, if foo bar ends with bar. So bar is present at the end and foo bar starts with foo. It starts with foo, it will return true. Second form of start with string start index. Okay. So it will give you from which index you have to start fetching the details. Here start index specifies index into the invoking string at which point the search will begin. For example, foo bar starts with bar 3, returns true. Equals versus equals to equals to. It is important to understand equals method and equal to operator are both different. Both are same, actually it seems to be same, but they perform different operations. Equals method compares the characters exactly inside the string object, and equal to operator compares two object references to see whether they refer to the same instance. The following program shows how two different string objects can contain the same characters, but references to these objects will not compare as equal. Okay, so we will see one example in that two different string objects are there. They contain the same character sequence, and references are different. Okay, so equal to give you whether they refer to same instance, and equals take the character sequence. Equals not equal to hello, and string s2 is equal to new string s1. Okay, so hello string is created with s1, then new string s1, from that s2 is created. S1 equals s2, s1 equals s2. It will give you true because both are giving you same character sequences. And s1 equal to s2 gives you both refer to the same string object. Both are not same, they are different. The variable s1 refers to the string instance created by hello. The object referred to by s2 is created with s1 as an initializer, so both will have the same character sequence hello. Thus the contents of two strings will be exactly same, but they are not same object, they are different object. S1 is different object, S2 is different object. S1 and S2 do not refer to same object. Okay, even the character sequence is same, they do not refer to the same object and are therefore not equal to, as is shown here by the output of the example. Hello equals hello true, hello equal to hello false. Okay. Compare to. It is not enough to simply know whether two strings are identical. Okay. So for sorting applications, you need to know which is less than, equal to, or greater than the next string. Okay, so like in sorting from A to Z characters, you need to know the which is less, which is equal, and which is greater than the other string. The string is less than another if it comes before the other in dictionary order from A to Z. A string is greater than another if it comes after the other in dictionary order. The string method compare to serves this purpose. Integer compared to string string. Here string is the string being compared with the invoking string. The result of the comparison is written and is interpreted as shown here. If it is less than 0, invoking string is less than another string. Okay. If it is greater than 0, invoking string is greater than string. And if it is 0, both are equal. Now is the time for all good men to come to the aid of their country. This is the string array. And what we are going to do, we are going to compare and sort the strings, okay, in alphabetical order. So how to do it? For j is equal to 0, j less than array len, j plus plus, and for I is equal to j plus 1. So now will be stored here, and from each to the country word, it is written line after line. Then array 1 compared to array of j less than 0. Okay. String t array of j is equal to array of I is equal to t. So what is this? This is a swapping operation. Why it is done? If the array of I means the next character after now, the next string after now, if it is less than in alphabetical order, if it is before this character, it is less than this string, then it will be swapped and your lesser string is stored over here. Okay, so we will see in that we will sort this array and then we will print this array. Okay, in alphabetical order using this temporary string t. Okay, so now we'll come first because now has the ASCII value before all the small letters A to Z. Okay, so it will come first. No matter what is the string over there, capital comes before small in ASCII table. Okay, so from A, then C, F, G, all are written in alphabetical order after now. Okay, so if you will replace this now with small n, it will come after this m. Okay, m and o. So it will not come at first. Output of this example compared to takes into account uppercase and lowercase letters. The word now come out before all the others because it begins with the uppercase letter. If you want to ignore case differences, you can use the compare to ignore case method. Okay, compare to ignore case, so it will not come as first. Now will not come as first string. It will give you same string result as compared to that case if differences are ignored. Try substituting it if you want. You can try substituting compare to ignore case. It will give you different result. So now in this case will come in the middle after m. Now searching string. The string class provides two methods that allow you to search a string for a specified character or substring. Index of searches for the first occurrence of the character or substring. Last index of searches for the last occurrence of character or substring. Okay. These two methods are overloaded in different ways. The methods return the index at which the character or substring was found or -1 or of failure. Okay. So what we are doing in searching string, we are searching a string for a specified character or a substring. We are checking that if particular character is there in that string or particular string or substring is there in that string. So index of will give you the first occurrence of the character or substring in the final string, and last index will give the last occurrence of the character. And whatever the case, if the substring is not found, it will give you -1. Otherwise, it will give you index. So you can specify starting point for the search. Index of integer character, integer start index, integer character, integer start index. This is index of, this is last index of. Then for string also there are methods: string, integer start index for index of, string, integer start index for last index of. Okay, so you can write down these 4 methods for the searching of string. Okay, and you can write down and learn this syntax to use in the actual application. Start index specifies the index at which point the search begins, or index of the search runs from start index to the end of the string. Last index of the search runs from the start index to 0. Or in the reverse order. The following example shows how to use the various index method for searching string. Okay, so now is time for all good men to come to the aid for of their country. Okay, so T will give index of T will give you the first index of first occurrence of the T inside this string. So where is T? 0, 1, 2, 3, 4, 5, 6, 7. Okay, so it will give you 7. First index of T is 7. Next, last index of T, then index of the, last index of the, index of T, 10. Okay, then index of T, 60. Okay, this is the start index. After this 10, where is the first occurrence of T? After 10th index, it will give you. Where is the last occurrence of T after this 60? In the reverse order from right to left, it will give you here. Then index of the from 10, index number 10, and last index of the index is 60. Okay, so it will give you different result. Index of, last index of, index of the, last index of the, and so on. Okay, modifying a string. Because string objects are immutable, whenever you want to modify string, you must either copy it into string buffer or a string builder, or use one of the following string methods, which will construct a new copy of the string with your modifications complete. Okay, so your original string will remain intact no matter what. If you want to change the original string, you can use the string buffer, as we have already seen in the previous session first slide. Substring. You can extract a substring using substring. It has 2 forms. First is string substring, integer start index. Here start index specifies the index at which the substring will begin. This form returns a copy of the substring that begins at start index and returns to the end of the invoking string. Okay, so start index will give you the index at which the substring will begin. Okay, from which index we have to find the substring, and it will return a copy of substring that begins at start index and runs to the end, whatever is the end of the string. The second form of substring allows you to specify both the start index and end index to find out the string. The start index specifies the beginning index, and end index gives you the stopping point. It will paste the particular substring from it. The string return contains all the characters from the beginning index up to, but not including the last string, that is ending index. The following program will give you the example of substring. This is a test. This is true. Is, was. Okay. So in result we will store the result. Okay. Original string is, this is test. This is true. So replace all matching substrings. System.out.println original. I is equal to original dot index of search. Okay. So first index of is, search is what? Is. So first index of is 0, 1, 2, 3. So it is 2. It will give you 2. If I is not equal to -1, we are finding the substring from 0 to 2. th. Okay, th will be fetched in this case. Okay, this is 2, 0, 1. From 0 to 2, 0, 1. It will give you. Then a result plus substring. From 0 to 2, it will give you th. Then th will be stored over here. It will give you result, and the result plus org dot substring I plus search dot length. Okay, result plus substring. Whatever result, it will be appended with the substring th. Then result is equal to original dot substring I plus search dot length. So what is I here? I is 2, and search dot length is its length is string length is 2, I plus 2. So it will give you is, and original is equal to result. So original will be replaced with the final result. Okay, this is test, this is true. Th is a test, this is true. Th was a test, this is true. Th was a test, this was true. And th was a test, th was true. Okay, so every each occurrence is replaced with was was in this case. Then concatenation. You can concatenate two strings using concat. String concat string string. This method creates a new object that contains the invoking string with the contents of string appended to the end. Okay, if you want to merge two strings, it will the method available is concatenation, that is concat. It will create a new object that contains the invoking string with the contents of string appended to the end. So whatever string you are giving, dot concat, and another string you are giving, it will give you the final string with first string plus another string. Concat performs the same function as concatenation plus operator. If string 1 s1 is 1 and string s2 is s1 dot concat 2, it will give you 1, 2. Okay, it generates the same result as 1 plus 2, that is 1, 2. Okay, then replace. Replace method has two forms. First, replaces all occurrences of one character into the invoking string with another character. All occurrences of one character in the invoking string with the another character, so it will be replaced. String replace character original with character replacement. So each will be replaced by was, like in the previous example. Original specifies the character to be replaced by the character specified by the replacement, and the result will be returned. For example, hello dot replace LW. So L will be replaced with W, and your resultant string will be HEWWO, that is hello. The second form of replace second form of replace replaces one character sequence with another. And string replaced character sequence original character sequence replacement. Okay, this form was added by J2AC5. Now next method is trim. The trim method returns a copy of the invoking string from which any leading and trailing white spaces has been removed. In this hello world, there is a white space before hello world and after hello world, and trim is called on that. So hello world, it will be returning. Okay, so white spaces is removed from the start to the start and the end of the string. The trim method is quite useful when you process user commands. The following program prompts the user for the name of state and then displays the state's capital. It uses string to remove any leading or trailing white spaces that may have inadvertently been entered by user. Okay, so if user is accidentally entering any white spaces, string will remove those white spaces. Okay, so buffer reader BR is equal to new buffer reader, new input string reader. So user will enter the string from your keyboard and enter stop to quit, enter state. If in this case, if user is entering a string, any white spaces, those will be removed. Buffer dot read line string dot remove white space. If string equals Illinois, capital is Springfield. If string equals Missouri, capital is Jefferson City. If string equals California, capital is Sacramento. If string equals Washington, capital is Olympia. If not a white string, not equals to stop. Okay, this is our program. So why we are used string over here? If there is space and if we are checking that string with equals method, that space will not be considered over here. So for the exact match, if the user is accidentally entering any white space into the input, it will be removed from the start and the end. Leading and trailing white spaces will be removed. Okay, so data conversion using value of the value of method converts data from its internal format into human readable form. That is string. It is static method that is overloaded within the string for all of the Java built-in types so that each type can be converted properly into a string. Value of is also overloaded for type object. So an object of any class type you create can also be used as an argument. Okay, object is a super class for all classes. It is a static method that is overloaded within a string for all of the Java built-in types, so that each type can be converted properly into a string. Value of is called when a string representation of some other type of data is needed. So if you want at any time the string representation of Boolean, if suppose it load, then it will be easy or it will be convenient for you to use the value of method. You can call this method directly with any data type and get a reasonable string representation of this data type. All of the simple types are converted to their common string representation. Any object that you pass to value of will return the result of the call to the object's toString data. You could just call toString directly and get the same result. For most arrays, value of returns a rather cryptic string which indicates that it is an array of some type. Okay. For arrays of character, however, string object is created that contains the character in the character array. Value of for all type of array, value of return the cryptic string which indicates that it is a array of some type, and for a character, string object is created that contains the characters in character array, and it will be merged and one string object will be created. There is a special version of value of that allows you to specify a subset of character array. Static string value of characters will be the start index, will be the number of characters. Here, characters is the array that holds the character. Start index is the index into the array of characters at which the desired substring begins, and number of characters specify the length of the substring. Okay. So value of will give you this first array specified over here. Then start index is given over here, and from this start index, how many number of characters I have to fetch, it will give you. Okay. Changing the case of the characters in the string. Two lowercase and two uppercase are methods to change the case of the character. The method two lowercase converts all the characters in a string from uppercase to lowercase. The uppercase method converts all the characters in a string from lowercase to uppercase. Non-alphabetical characters such as digits are unaffected. Here are the general forms of these methods, two lowercase and uppercase. Both methods will return a string object that contains the uppercase or lowercase equivalent of the invoking string. This is test to uppercase and to lowercase. This is test will be converted to all letters capital in this case, and it will return you upper, and this will return you lower. Okay, this is test will give you this is test, and the lowercase will give you this is the test. Now we will see some more methods. In addition to those methods, string includes several another methods, and both are added by J2SE5. We will see those in the following tables. Okay. So integer code point at integer at returns the Unicode code point at the location specified by I, added by Java 2 SE5. The code point before returns the Unicode code point at the location that precedes that specified by I, added by Java 2 SE5. The code point count, integer start, integer end, returns the number of code points in the portion of the invoking string that are between start and end minus 1, added by J2SE5. Boolean contains character sequence. Returns true if the invoking object contains the string specified by the string. Returns false otherwise. Boolean content equals character sequence string. Returns true if the invoking string contains the same string as string specified in the parameter. Otherwise, it will return false. Boolean content equals string buffer string. Okay, so content equals previous form and this form has one difference. First is having character sequence object and second is having string buffer object. Returns true if the invoking string contains the same string as string, otherwise it will return false. Static string format string object arguments. Returns a string formatted as specified by format string. String we will see in this coming chapter 18. Okay. Then static string format local string format string object arguments. Returns a string formatted as specified by formatted string. Formatting is governed by the local specified by the local object. Boolean matches string region expression. Returns true if invoking string matches the regular expression passed in the regular expression. Otherwise, return false. Integer offset by code point, integer start, integer num. Returns the index at with the invoking string that is num code point beyond the starting index specified by the start, added by J2SE5. String replace first string string regular expression, string new string returns a string in which the first substring that matches the regular expression specified by regular expression is replaced by new string. String replace all string regular expression, string new string returns a string in which all substring that match the regular expression specified by regular expression are replaced by new string. So it will only replace first and it will replace the all. Okay. All substring it will replace. String split string regular expression decomposes the invoking string into parts and returns an array that contains the result. Each part is delimited by the regular expression passed in the regular expression. Then string split string regular expression integer maximum decomposes the invoking string into parts and returns an array that contains the result. Each part is delimited by the regular expression passed in regular expression. The number of pieces is specified by max. If max is negative, then the string is fully decomposed. Otherwise, if max contains non-zero value, the last entry in the return array contains the remainder of the invoking string. If max is 0, the invoking string is fully decomposed. Character sequence, subsequence, integer start index, integer stop index. Returns the substring of the invoking string beginning at start index and stopping at stop index. This method is required by the character sequence interface, which is now implemented by string. Okay. So these are the methods added by J2SE5. You can use this chart. Okay, you can note this down. You can take a photo. You can take a screenshot of this method, and you can practice it by your own to find out how exactly the output is coming. Okay, you can see the description and use those methods by the syntax in your application and understand how they are actually working. Then string buffer. String buffer is a peer class of string that provides much of the functionality of strings. As you know, string represent fixed length immutable character sequences. Those are non-changing. Okay. In contrast, string buffer represents throwable and writable character sequences in which whatever modifications we are doing, those will be present there. String buffer may have characters and substring inserted in the middle or appended to the end. Okay. String buffer will automatically grow to make room for such additions and often has more characters pre-allocated than are actually needed to allow for growth. Okay. So first of all, they will automatically grow. Okay, if you are making any addition or any changes to the string buffer object, they will automatically grow and often has more characters pre-allocated than are actually needed at start itself to allow room for the growth. Java uses both classes heavily, but many programmers deal only with string and let Java manipulate string buffers behind the scenes by using the overloaded plus operator. String buffer constructors. Okay, so 4 constructors are there: string buffer default constructor, string buffer integer size, string buffer string, string buffer character sequence characters. The default constructor, the one with no parameters, reserves room for 16 characters without reallocation. The second version accepts an integer argument that explicitly sets the size of the buffer. Okay, so first we'll give you 16 characters length without reallocation. Second will give you second accept the integer argument that explicitly sets the size of the buffer, whatever size we will specify over there. Then the third version accept the string argument that sets the initial contents of the string buffer that will be initialized with the specified string and reserves room for 16 more characters without reallocation. The string buffer allocates room for 16 additional characters and no specific buffer length is requested because reallocation is costly process in terms of time. Okay, when you are not giving any length at start, it will give you room for the 16 additional characters. Also, frequent reallocation can fragment memory. Okay, so memory fragmentation will there. Time complexity. Regarding time complexity, it is costly. So it will make a room for 16 additional characters at start itself. By allocating room for few extra characters, string buffer reduces the number of reallocation that take place. The fourth constructor, that is string buffer character sequence characters, creates an object that contains the character sequence contained in gaps. Okay, length and capacity methods. The current length of string buffer can be found via length method, while the total allocated capacity can be found through the capacity method. Integer length, integer capacity. Okay, so we will see the example. String buffer SB is equal to new string buffer hello, SB dot length, SB dot capacity. And output is buffer hello, length is 5, capacity is 21. So 5 plus 16, so 16 additional characters are given, so capacity is 21 in this case. SB is initialized with the string hello, and when it is created and its length is 5, its capacity is 21 because room for 16 additional characters is automatically